Hello everyone, welcome back to the series. This is episode 7 of building a chat app in C from scratch. In the last episode, we implemented a more advanced input box system. So we implemented features like cursor blinking. You guys can see we can type hello, how are you, everything is good. We also added multi-byte support, so we can input UTF-8 characters like emojis and all of those stuff. As you guys can see here, we can send messages and all of that. Today, we're gonna be implementing our chat server. So we'll be doing some network programming, so we can actually start doing some real communication using our chat app. Now, please remember to hit the like and subscribe button, guys, and let's jump right into the video. Alright guys, so let's create in our server. So let's create a server.c file and let's start writing. So we'll say, if you guys notice, by the way, I'm on Windows. Creating this server will be different on other platforms, so we'll just, to keep it simple, we'll first create the server for Windows, and then we'll make it cross-platform after I finish creating the server on Windows. So it will work on Linux and macOS and all of those other different operating systems. So to create our server, guys, so we created our server.c file already. We'll do a hash if not defined win32 lean and mean right here. Hash and def right there. Inside of here, we're gonna define a win32 lean and mean. We're then gonna say hash include windows.h. We'll then say hash include winsock2.h. Above here, we'll do a hash pragma comment ws2_32.lib. And now that we have done that, guys, we can create our main function and then we can start creating our server. So guys, we first need to initialize our Windows Socket API. The reason why we also did this up here is because there are multiple versions of the Windows Socket. Like if I write hash include winsock, you can see there's winsock.h and winsock2.h. That is the old version of Windows Socket. So in order to prevent collisions, we need to define this up here, because we're going to be using the latest Windows API. So now that we have done that, we can start creating our server. So first thing, guys, we need to initialize the Windows Socket API by calling WSA startup. We also need to ensure that we define a WSA data variable. We'll also need to, inside of our WSA startup function call, we'll specify the version of Windows Socket API we want to use. In this case, we'll be using version 2.2, which is the latest version. So we'll do a make word 2,2 right here. And then we'll then pass in a pointer to our WSA data structure. We'll then start creating our socket. Now guys, if you don't know what a socket is, it's essentially a file descriptor that our operating system will give us, which will allow us for two programs to communicate with each other over a network. So let's create our socket now. So we'll just write socket sock. So sock fd or socket file descriptor is equal to socket We'll specify AFINet because we want to be using IPv4 addresses. The type of our socket will be sock stream because we want full duplex communication. Our protocol will leave it at 0. We'll then need to specify an address that we want to bind to for our server, guys. So we'll do a struct sock addr address. Address is equal, let's just leave it like that for now. So we'll just say addr dot scene underscore family equals to AFINet, then addr dot scene underscore address dot s underscore address is equal to inaddr any. That inaddr any will essentially be our IP address 0.0.0, which will allow us to listen on all available IP addresses that are present on our computer. And then now, guys, we'll then say addr.scene underscore port is equal to htons port. We'll need to define a port up here, so hash define port. Let's make it be 777. And we'll pass in our port right here. This htons function, what it does, it converts our port from host byte order into network byte order. That the computer can understand. So once we have done that, guys, we can bind to our socket file descriptor. So we'll cast our address to a struct sock addr pointer. We'll pass in a reference to our address. We'll then specify the size of our address structure. Once we have done that, we can then start listening on our socket because we want to listen for a connection. So we'll call our listen function, pass in our socket file descriptor, and then we'll want to listen indefinitely, so we'll pass the 0 flag in there. And then now, guys, after we have listened, we can literally just print a message right here. You can say listening on 0.0.0 colon mod d new line, and let's just pass in our port right here. And then now, guys, we need to accept a connection. So we'll create a socket. Let's call it csockfd, which will be our client socket file descriptor. We'll then say call our accept function, which will take in our server socket file descriptor. And then we will pass in a struct sock addr pointer. So we'll cast it, and then we'll pass in our caddr. Let's create a variable called caddr, which will be our client address, because we'll print it out once we get a connection. So we'll create a struct sock addr in c address, and then we'll create another variable, guys. Let's call it caddr length. We'll make it equal to the size of caddr, which is the size of our struct sock addr in structure. We'll then need to pass in a pointer to our caddr length variable. And then after we have done that, guys, we can just print out a message. Let's say got connection from %s colon mod d. So we print out the IP address and the port number of the connection that we got. And then we'll use the inet ntoa function. We'll then pass in our client address dot scene underscore address property. We'll then pass in ntohs caddr.scene underscore port. Yeah, what these two functions does, guys, the SINET and TOA, it will essentially convert our address from network byte order into host byte order, but it will be a ASCII string. And then the NTOHS, it will essentially convert it from network byte order, which is our port, to host byte order. And the H turns up here, it will essentially convert our port number that we want to listen on into network byte order. And once we have done that, guys, we can literally start sending a message to our client. So let's create two variables because we're going to be sending and receiving messages from our client and from our server. So we'll have a message, guys. So let's make a char message equals to hello from server. We'll have a buffer. We'll make it a default size of 1024 bytes. We'll initialize it to 0. After we have done that, guys, we'll send our message to our client. So we'll pass in a csockfd, which will be our client socket, and then we'll pass in our message. Then we'll pass in the size of our message. Then we'll pass in a flag, which will be 0 for now. We'll then receive a message from our client. We'll then say csockfd. Then we'll pass in our buffer that we'll receive it in. Then we'll pass in 1024 bytes because that's the size of our buffer. Our flag will be 0 by default. So we'll print out a message, the message that we received from our client. We'll print out something like, we'll do a printf received message from client modulus s new line buff. We'll then say close csockfd. So we'll need to close close socket csockfd, so because we'll need to close the file descriptor that our client is on. And then we'll need to close our server socket. So we'll do a close socket, sockfd, and then we'll need to ensure that we uninitialize the Windows socket API. So we'll call WSA cleanup, and that will literally be our server, guys. Now let's create a simple client that we can use to interact with our server. So let's create a simple client.c. So we'll do the same thing, guys. We'll literally say hash if not defined win32 lean and mean. We'll then define a win32 lean and mean hash ended. We'll do a hash pragma comment. We'll then say ws232.lib. We'll then say hash include winsock2.h, hash include windows.h, and then we can need to also include stdio.h. We can do an int main now, return 0. Now, guys, we'll need to create a socket for our client, so we'll just call it socket sock. But we also need to remember an important thing, to initialize our Windows socket API. So we'll create a WSA data structure. So WSA data. We'll then initialize it using the WSA startup function. We'll do a make word 2, 2. We'll then pass in our WSA data structure, a reference to it. We'll then create our socket now, guys. So we'll say socket sock equals to socket af inet For IPv4, type sock stream for full duplex communication, protocol 0. We'll then say we'll define an address that we'll connect to, guys. So we'll do a struct sock addr in address, and or we'll then say address.scene funnel equals AFINet. We'll then say address.scene underscore address.s underscore address equals inet addr 127.0.0.1. So we'll essentially connect to this IP address, which is our local host address. This inet addr function, guys, it will essentially convert this string into network byte order, or the binary format that the computer can understand, So we'll then define the port that we want to connect to. In this case, our server will be listening on port 777. So we'll specify the port in here. So addr.scene underscore port equals to htons 777. But let's just define this within a variable. So, or a macro. So we'll say hash define port 7777. And then now, guys, once we have done that, we can start connecting to our server. So we'll call the connect function, we'll pass in our socket, we'll cast our address structure into a struct sock addr pointer, pass in a reference to our address. We'll then need to pass in the size of our address structure. And once we have done that, guys, we need to start sending a message. So we'll create a char message, and let's just call it equal to hello from client, and we'll create a buffer that will receive a message into from our server. So 1024 bytes. We'll then say send our message to our server. So we'll do send sock message, size of our message, and then 0. Then we'll say receive buff, receive one from our socket into our buffer, 1024 bytes, flags 0. And then now, guys, we'll then say we'll close our socket. So we'll do close socket sock, and then we'll then say WSA cleanup. Then we'll pass in our socket. So now that we have done that, guys, let's start testing it out. So let's compile our server, guys. So we'll type gcc server.c within our terminal. Wait, let's just open up two command prompts. So we'll do a start cmd.exe, and we'll do another start cmd.exe again. So now, guys, we have two windows beside one another. Now we can do gcc server.c -lws232 because we want to link with the Windows socket API. We'll do a -o server, so we get a server.exe file. Alright, so we have an error. Oh, that's because we need to include the stdio.h. So let's do that in our server.c. So we'll do hash include stdio.h. So now, guys, we can literally just recompile our code. Alright, so now that our server has compiled, let's run it. So we'll just type server in our terminal. You can see it prompts us to listen to allow access. We'll click allow. Alright, so now guys, let's compile our server. So gcc client.c-o client. Oh, we also need to link to the Windows socket API. So -lws232-o client. Alright, so we have a simple error, too many arguments to function. Oh, that's because it doesn't accept any argument in our client. So we just need to delete that. And let's recompile our code. Alright. So we have a error. Wait, what did it say? Cannot find. Wait, -lws2. Wait. Oh. Yeah, my bad, guys. I didn't even realize I put an equal sign here. It should be -l. So now, guys, we can rerun our server. And we can now execute, or we can now recompile our client, and then we can execute our client. So you guys can see the server got a connection on this IP address and port number. It received a message, hello from client. We also forgot to print out the message that the client received. So let's do that real quick. So we'll just do a printf in our client.c. Receive the message from server modulus new line buff. And then let's recompile our code now, guys. So we'll run our gcc compile command for our server. And let's recompile our client. And now let's run our server. And now let's run our client. So now, guys, you can see our client got a message from our server saying hello from server and hello from client. Now, guys, let's change this message to say something. Let's make it say hello from hello, welcome to the server. How are you today, for example? And our client will say something like, hello, dear server, I am doing great. So now that we have done that, guys, let's just recompile our code for both our server and our client. So let's execute our server. Let's recompile our client now. And let's execute our client. So you guys can see in our console right here, received message from client, hello dear server, I am doing great. Also the server said, hello, welcome to the server, how are you today? So now that we have done that, guys, let's start by making our server multi-threaded. So making our server multi-threaded will allow us to allow multiple clients to connect to our server, right? Because right now it's only one client and one server. So let's do that right now. So we'll need to include our multi-threading header file. In this case, we'll be using pthread for now. Pthread is not cross-platform, but for now we'll just use pthread because yeah, it's just POSIX threads, you know. But MSys allows us to use pthreads, so that's why we're gonna be using it for now. So let's start doing that. So we'll include our pthread.h header file, guys. So hash include pthread.h. And we'll essentially, guys, just wrap our receive and send thing. No, we'll wrap our accept function within a while loop for now. Yeah, let's just do that for now. So once we do that, guys, yeah, we don't even have to use pthread, to be honest, for now, until we actually start making our server more, you know, like actually work with our GUI chat up. Yeah, let's just recompile our server and let's run it. And then now, guys, we can do something like this. So we'll recompile our client. You guys can see our server is still listening for our client. So we can rerun our client multiple times now. Yeah. And we can literally communicate between one another. Right? So here's what we're gonna do now, guys. We're gonna refactor all of these code into a simple socket library that we can use later on. So let's create a chat server.h. No, let's not call it that. Rename it to a chat socket.h header file. And we'll define a chat socket.c as well. Alright, guys, so here's what we're gonna do. Oh, also I forgot to show you guys something. So this only works on Windows right now, right? So if I open up like my WSL terminal and try to compile the code for Linux, here's what's gonna happen. Yeah, let's wait for this to load. Alright, so if I try to compile my code on Linux, guys, for the server, for example, so I type gcc and let's say server.c-to server, you guys can see it has a error, and that's because we on different platforms, guys, like on Windows specifically, we have to use the Windows socket library. So to fix this, guys, we'll need to check the platform we're on. So we'll do a hash if not defined, hash if def up here, underscore win32. So if we're on Windows, then we will include these libraries and we'll do all of these stuff here. We'll then do a hash else right here and a hash endif right here. And in between here, guys, we'll need to include the sys/socket.h. We'll then include the Unix standard library.h header file. We'll also need to include the arpa/inet.h header file. So if we recompile our code now, guys, we will still get an error, but I just want to show you the error will change now. Now this WSA data and all of those stuff, that's only specific to Windows. So we'll need to do a hash ifdef win32 right here. Then we'll do all of these stuff. Otherwise, if we're on Linux, we'll do a else right here, and we'll say int sock fd. Let's do an int sock fd right here, and let's just copy this and just put a semicolon right there. And right here, guys, we'll just say sock fd equal to that, right? So we'll essentially define our socket file descriptor differently based on the platform we're on. So if we're on Linux or Mac, it will be an integer, and if it's on Windows, it will just be our socket definition that Windows uses. And we'll need to do it for this closed socket thing as well. So we'll say hash ifdef win32. Then we'll do a hash endif right here. We'll do a hash else, and we'll just do a close sock fd if we're on Linux or another platform. And this closed socket right here, we need to replace that as well. So we'll do a hash ifdef win32 hash else close csock fd hash endif. And now if we recompile our code on Linux, guys, look at this. So we recompile our server. It says unknown type socket. Oh, that's because we need to do another preprocessor right here, guys. So we'll do a hash ifdef win32 csock fd. Yeah, let's not do it in here. Let's do it out of here instead. So we'll say hash ifdef hash endif csock fd equals to, yeah, let's just define it, I guess, you know. And inside of this loop, we'll just say csock fd equals to accept. And we'll need to do a hash else right here. We'll say int csock fd. And let's try to recompile our code now. So if we, you can see it compiled successfully, guys. So if we rerun our server now, and let's open up another split screen right here. We'll try to compile our client. So gcc client.c-o client. We'll get the same error. So we'll need to do this for our client as well. So we'll say hash ifdef win32 else. Then we'll do a hash include arpa inet.h hash include /socket.h. We'll also do a hash include unicd.h. And we'll need to do another preprocessor here as well. /def win32. We'll do a else #ndif. We'll say int sock. We'll then say do another hash ndif right here. So we'll say #ifdef win32. We'll then say #endif #else close sock. And that should be it. So if we recompile our client now, it should work. So if we run our client, you can see it works, guys. Can rerun it as many times as we want, and our server will accept it, right? So now that we have done that, guys, let's start refactoring our server into, by creating a simple socket library that we'll use. So we created our chatsock.h. Okay, let me just close these windows for now. So we'll need to include these header files that we have right here. So we'll just copy all of these up here from our server.c, and we'll place it inside of here. Let's actually define a header guard for our chat socket. So let's do a hash, if not defined, chatsock _h hash define _chatsock _socket _h. And let's do a #endif down here. Alright, so now that we have done that, guys, we'll create some structures for now. Let's see. So we'll do some type definitions, guys. So it happens that our socket is different on multiple platforms. So it will be an int on Linux and Mac, and socket on Windows. So we'll do the same thing up here. So within where we check if we're on Windows and on other platforms, we'll do a type def. Let's say int. Type def socket, and we'll say chatsock _t. Yeah, let's just call it chatsock _t, and we'll do another type def. Let's just call it type def int chatsock _t. We'll then let's say, that's it, guys, for now. Let's create our own close function, right? So let's create a void chatsock _init function. And we'll create a void chatsock _ let's call it destroy. yeah, and so in our chat init function, let's go into our chat socket.c file, and we'll just copy these type defs for now. So we'll say #ifdef win32 #endif #else. We'll say WSA data right here. Oh, we also need to remember to include our chat socket.h. We'll then say WSA startup. We'll then say make word 2,2 %WSA data. So you guys can see we're literally extracting these initialization stuff, just to make our lives a little easier. Yeah. So let's create our destroy function now, which will literally uninitialize our socket library. So inside of here, we'll literally just do a #ifdef win32 #endif. Then we'll just call WSA cleanup, and that will be it for those two functions. We'll then do a void chatsock underscore, let's say, let's not make it a void, but actually a chatsock underscore t. So chatsock underscore create will essentially create a socket for us. We'll also have a void chatsock close function, which will accept a chatsock t sock. And then let's create these two functions by copying their prototypes. So we'll literally just copy all of these stuff, guys. Let's see. So to create a socket, we just need to do this. So we'll just say chatsock underscore t new socket, new sock equals to socket if init sock stream 0, and then we'll just return a new socket. Yeah. But also, guys, here's the thing too. We're gonna have like a little abstraction, right? So when we have a socket, we also want to have an address associated with it, right? So let's actually create a structure, So we'll do a type def. Yeah, let's create another file. Let's call it chatsocket underscore def.h hash if not defined chatsock def.h on def underscore h hash define chat sock def h hash ndef. You guys, we can literally just copy all of this and paste it in here. And then in our chat socket.h, we can do a hash include chat socket def.h. And now, guys, let's define a structure. So we'll do a type def struct. Let's just call it, chat sock. So chat underscore sock. We'll do a chat sock t. Yeah, we'll literally change this type def, guys. Let's just call it chat sock fdt, and let's just call the chat sock fdt chat sock underscore fdt, and then we'll say or chat socket structure will have a chat sock fdt socket. It will then have a struct sock addr in address for that socket. Yeah, and then it will also have a address length. Now on Linux, we'll need to do a type def. We'll have a sock length t, right? So on Linux, so we'll do a let's do it in here. So we'll say hash ifdef win32, then we'll have a int address length, then we'll do a hash else, and we'll say sock length t address length. And that, let's leave it like that for now, guys. So now we can do our create function. So chat sock, chat underscore sock. So in our create socket.c, guys, we'll need to modify this a bit. So our new socket our new socket will later take in a address now let's see how we'll process that address, right? So let's think about how we'll do this. Because our address will need to be converted. Right? So Let's make our chat suck create taking a int port, and let's let it take in a const sharp pointer address, and let's make that be it for now. So let's just replace our function definition right here. Okay, with that. So we'll basically set our thing right here. Alright, so we'll do a new socket dot sock is equal to socket. Let's just copy this from our server, and we'll just paste it right here. We'll then say new sock dot address is equal to let's see, let's define a struct sock addr in new address, and just to simplify this, we'll just say above here, we'll say dot scene family equals afinet dot scene address dot saddr is equal to our address. We'll then say dot is equal to inet addr address. We'll then say dot scene underscore port is equal to htons port, and that will be it. Now our close thing now, guys, will essentially say void chat sock underscore close, right? So it will essentially do so we'll say if we're on Windows, then we will use the close socket function on our socket. Right, so we'll take in our chat socket, so chat underscore sock, which has our socket, and then if we're on Linux, we'll just say close chat sock sock. And that will literally be those functions, guys. Now we have this bind thing right here. We'll abstract this bind into a chat sock bind function. So we'll have a void chat sock bind, chat sock underscore t So we'll take in a chat socket, and we'll also have a chat sock listen, chat sock t, chat socket. We'll also have a void chat sock accept, chat sock t, chat sock. So it will take in a chat socket. Yeah, let's just let it return a new chat socket. Alright. So let's just copy these function prototypes now. Alright, so for our bind, we will essentially need our socket file descriptor. You know what, guys? Like in our chat socket structure, instead of calling this sock, let's just call it sockfd. We'll replace it with sockfd, sockfd. So our bind function now, so it will just take in a chat socket and then our socket file descriptor. Oh, this should also be a dot, guys. Oh, and also, guys, this should be a pointer actually. Let's make this a pointer. Let's make all of these a pointer. Alright, so all of these should be pointers. So our address will just be our chat socket address, and then the size of our chat socket address. And let's change the type of this to return an int. So, because we'll do error handling later on. And let's make this an int as well. And yeah. Yeah, our listen will be an int as well. So in order to, so we'll just return the return value of our bind call from this function, and our listen, we'll just say return listen chat sockfd 0. And for our accept, let's just copy the accept from our server .c. And then now, guys, let's pass in our chat socket file descriptor. This should be a pointer. And then now guys, we can pass in, so we'll need to return a chat socket T, right, of our client that is connected to our server. So we'll have a chat sock T. Let's make that our new socket. Or let's just call this new client. We'll just return our new client. So we'll pass in a pointer to our new client. We'll pass in a new client dot address length. We'll say new client dot address length is equal to the size of new client dot address. And then guys, can just return that new client. And yeah, that should be our chat socket for now. Alright, so our create as an error. Yeah, instead of doing .sock fd every time, guys, let's just replace that in our chat sock def with just fd. So we'll just say new sock.fd, and we can just do chat sock fd. Let's do a find and replace by pressing Ctrl H. We'll find sock fd. We'll replace it with fd. Alright, so now that we have done that, we can save this. Let's replace chat underscore sock with chat sock. Let's do the same thing for our chat sock.c. Alright, so now that we have done that, guys, let's try to test out our socket library. So we'll simplify all of this code in our server.c and start using our chat socket.c. So let's do that. So all we'll need to do, we'll need to remove all of these initialization things, right? So in our chat socket, so we'll essentially include our chat socket.h header file. So hash include chat socket.h. And then now, guys, we can literally remove this up here. We'll replace this sock fd with just chat sock underscore create, which takes in a address. Now, if you notice, guys, we have this in addr anything. No, that's essentially an integer. So here's what we're gonna do. Yeah, we can literally just do a chat sock create 0.0.0 0, and then we'll pass in our port, and then we will get a chat sock t socket equal to chat sock create, and then we can literally just remove this right here, guys. This bind, we can replace it with chat sock bind. We'll pass in our socket structure that we have. We'll also replace our listen with the chat sock listen. Yeah, this should be a pointer, guys. So a reference to that. Yeah, we'll also replace all of this, and we'll just say chat sock t. Let's call it csock equals to chat sock accept, and we'll pass in a socket or chat sock, and that's all. And it should be a pointer, and we'll also replace. Oh, we don't need to do that yet. This is where we actually need to do it. So we'll say csock equals to chat sock accept %csock. Let's create another function, guys. Wait, let's not do that as yet. So we'll just say csock address.scene_address, and we'll say csock.address.scene_port. We'll then say csock.fd right here. We'll then say csock.fd again right there. Yeah, this close, we'll replace it with chat sock close. We'll pass in our csock, and all of these right here, we'll replace it with chat sock close socket. This forgot a semicolon there. We'll then say chat sock destroy. So chat sock close, it accepts a pointer. Alright. So now, guys, you can see how simple our server looks now that we have simplified it a bit. So let's actually test out our server. So we'll do a start cmd.exe, and we'll do another start cmd.exe. Alright. So now we're gonna try to compile our server and see if it works. So we'll do a gcc server.c. We'll then do a chat socket.c -l ws2_32-o server. Let's see if we get any compilation errors. No, we don't. Let's run our server. Why is that happening? Alright, so we're saying we got a connection from our server, but that's not supposed to happen. Alright, so let's look at our chat-sock accept function. So we return or listen right here. Alright, let's comment out some stuff for now. So let's do it. And let's recompile our server. And let's see what's going on. So it says it's listening. Okay, that's good. Is it just our, so it's just our accept thing. Oh, we pass in our client socket and we're not supposed to pass in that. It should be our server socket. So that's why it wasn't working, guys. So if we rerun our compilation, we recompile our code, then we execute our server. Wait, hold on, what? So we recompile our server. Ah, I see. Chat-sock accept new client. So we accept on our server. Ah, I see. So it should be our new client dot fd equals to accept, because we'll get the file descriptor, guys. And then let's try to recompile and see what happens. Alright, so it will say that so we pass in our new client. Oh, I see. So this should be our new client address right here. So let's recompile our code again, guys. Wait, we have an error. What's that? Yeah, it should be new client dot address. And if we recompile, execute our server, alright, I wonder if it's because we're essentially returning from here. Because it should work, guys. So So new client address length, new client fd equals to accept chat sock fd. Okay, address length. Wait, let's see something. So we recompile our code. We execute our server. Let's try to compile our client. .c. And let's try to execute it. It says it received a message from the server. Ah. Okay. Wait, maybe guys, or accept. Wait, let's see something. So I'm gonna just copy this accept right here, guys. And I'm gonna paste it right here. I'm then gonna say csock.fd is equal to accept sock fd. We'll then say csock.address, then csock.address length, so our dot address length will be equal to the size of our chat sock, no, our struct sock addr in structure. Well, this should be sock.fd, then csock.address length, alright. So now let's try to recompile our code. Alright, and we have a bunch of errors. fd undeclared. Okay, this should be sock.fd. And let's recompile. Alright, so if we execute our server, it still fails. Did we fail to bind to the socket? So we'll say if chat sock bind is less than 0, cd error failed to bind to the socket. We'll then say if chat sock listen is less than 0, printf std error failed to listen on the socket. And let's comment right here, guys. So we do a GCC. Let's execute. Failed to bind to the socket. Failed to listen on the socket. Why is that? Alright, so we bind to our chat socket. Okay. Wait, let's see something, guys. So if I go to the server.c, is it because of that 127.0.0.0? Alright, so if we recompile our code now, it should work, right? Oh, it still said failed to bind to the socket. Oh, we forgot to initialize our chat socket, guys. So we need to first call chat socket init. And then it will start working. So if we recompile our code now, and then we execute our server, it should work. It still doesn't. Wait, chat socket init. WSA data. Wait, let me copy this, guys, for a second. Let's replace this with just this. Let's rerun another command prompt. And let's recompile our server. It still failed to bind for some reason. Wait, let's try it again one more time. So we compile our server.c, link it with our chat socket.c. We execute our server. It still failed to bind for some reason. So that's not the issue. So we still need to call our chat socket init. New address. Wait, so we have our new address right here, guys, but we forgot to assign it. So we need to say new sock.address equals to our new address. And that should fix the issue. Right, so let's recompile our server now. And let's see if it works. Alright, there we go. So now, guys, we can test out our accept thing and see what's going on. So We recompile our server.c. Then execute our server. And let's recompile our client. And let's execute our client. Alright, so there we have it, guys. Everything is working fine now. Our library is working as it's supposed to. Now let's actually try to use our actual accept function. So we'll just say csock equals to accept equal to chatsock accept. We'll pass in our socket. Yeah, and we can just delete all of that for now. And let's try to recompile our server. Alright, execute it now. And let's run our client. Yep, and it works, guys. So now we can actually simplify the send and receive. Right, so we're gonna abstract this send and receive. So we're gonna create some prototypes real quick. We'll say void chatsock underscore send, and it will take in a chatsock t chatsock and we'll also have a void chatsock receive chatsock t chatsock. It will essentially take in a void pointer. Let's just call it ptr, and then a size t. Yeah, let's just call it buffer, and then buff size, and then a void pointer buff size t buff size. And let's implement these functions now. So we'll just paste that in, or chatsocket.c. We'll then say we'll then just copy these send and receives. So that's send, and that's receive right there. So we'll make these return types for these functions be an int, which is the same for the send and receive thing. So let's change this prototype to an int. Alright. So we'll just do a return send chatsock.fd. Then we'll pass in our buffer. Then we'll pass in our buffer size. Then we'll then say pass in our chat socket again .fd, then our buffer, then our buffer size for our receive, and we'll just return the returned value of receive. So now let's replace these now, guys. So we'll just call chatsock send message size of our message, and we'll pass in our csock we'll then have our chatsock receive, which will just be our buffer, and then 1024 bytes. Alright. So now that we have done that, guys, let's test it out real quick. So we recompile our server, execute it, and let's execute our client, and it still works. Nice. So now, guys, let's try to close all of these header files for now, and let's try to simplify our client. So to use our socket, so we'll do a delete all of that, then we'll do a hash include chatsocket.h. We'll also delete all of this as well, and we'll replace it with chatsock_init. Now, guys, it's kinda annoying to always call chatsock_init all the time. So here's what I'm gonna do. I'm gonna place it inside of this. Wait, let's not do that. Let's just keep it as it is for now. And this socket, guys, will just make it a chatsock_tsock. This address, we will get rid of it. We'll then just say chatsock sock equals to chatsock create, then we'll pass in 127.0.0.1, and the port will just be that port. Let's implement a connect function real quick. So we'll open up our chatsocket.h and our chatsock.c. We'll define a connect function. So it will be a int chatsock_connect chatsock_t chatsock. And then now, guys, let's actually define that function real quick. So let's just paste this in, and our connect will just, let's just copy this connect, and we'll say, we'll pass in our chatsock fd. We'll then pass in our chatsock address. We'll then pass in the size of our chatsock address, and we'll ensure that we return the return value of that connect function. Now, guys, that we can just do a chatsock connect, then we'll pass in that socket there, which will be a pointer to that. We'll then say chatsock send to our socket, our message, then the size of our message. We'll then do a chatsock receive, which will be your socket, and then our buffer, then the size of our buffer. And then we can literally just replace all of this now, guys. Just chatsock close socket, and we can then say chatsock destroy, And look how much simpler our client is now, guys. Alright, so now that we have done that, let's try to recompile our code. So we'll do a gcc server.c. Alright, so we recompiled our code. Now let's try to recompile our client. Alright, so we get an error. Implicit declaration of function chatsock connect. Oh, it should be chatsock connect, right? Let's recompile it again. Our client chatsock close. Oh, this should accept a pointer. And yeah, let's recompile our code now. So if we do a gcc we need to link with our chatsocket.c file. Alright, so now that we have done that, guys, let's execute our client. And you guys can see we have a simplified library. Alright. Now guys, let's just rename this to, instead of chatsocket.ch and chatsocket.c, I'm just gonna rename this to chatsock.h. And let's rename this to chatsock.def.h. Let's rename this to chatsock.c. And let's replace this with chatsock.def.h. That means we'll need to go in our server.c, and we'll need to replace this with that as well. Right, so now guys, we implemented that library. Alright, so let's recompile our code real quick to test it out. So we'll do a gcc. Alright, so we need to link with our chatsock.c instead. Oh, so we forgot to do something. Yeah, we need to modify our chatsock.c to include our chatsock.h. And now if we recompile our code, it should work. Alright, so now we can execute our server, guys. And we can try to recompile our client now. Let's replace this with chatsock.c. And let's execute our client. So you guys can see everything is working fine now. Alright. So this will be it for today's videos, guys. So we essentially implemented our simple socket library that we'll use. We implemented a basic server, and we implemented a basic client to showcase how our GUI chat application will work. So in the next video, guys, we'll implement broadcasting in our server. We'll also start integrating our client into our GUI or actual chat application, as you guys can see here. So then now we'll be able to, for example, so here's our server. We'll be able to type a message like, for example, hello. And we could have like, let's say, let me show you guys something. We could have like multiple persons talking to one another. So this is our chat application, right? So right here is our server, and here's one of our other ones right here. Yeah, let's just resize this. All right, so here is our server, guys, and here are our clients, right? So our chat application will essentially connect to our server, and it will broadcast it or relay our messages, right? So that will allow us to talk to one another or send messages to one another. So that will be it for today's video, guys. Thank you guys for watching. Don't forget to hit the like and subscribe button. Also, guys, I want you to recommend a name for the chat application that we're working on, because right now it's just called Chat Up. So you can comment down below. So thank you guys for watching. Hit the like and subscribe button, and I'll see you in the next video.